I thought for a long time to really provide a video that kind of like helps me a little bit with showing you how I debug stuff through Verilog and simulation. And particularly, I'm doing this in through ModelSim. You could use whatever tool that you actually like to use, VCS or whatever tool, but I'm going to particularly show in ModelSim. So what I'm going to show today is basically I have a formed Verilog file in here, and here's the Verilog file that I have, and I purposely put an error in this file. I have a test bench, which I almost always write in System Verilog just because it's so much easier to actually write. I have some random inputs in here, and I'm going to run it through a do file, which I've mentioned in my earlier kinds of videos. So I just called it, for lack of better names, google.do. Okay, so what I want to do is I want to just try to run this through. So I'll do vsim minus do google.do, and hopefully let's see what happens. So it pulls up our ModelSim. It doesn't matter. This should work for whatever version that you actually have. You actually see it opens two windows here. Here's my main ModelSim window, and I have my wave file sort of detached. You can click the line here. This is that file here, and you can see I have a specific error, these red lines, which are really bad. So I want to really try to figure out what's going on with this type of system and seeing how I can figure out. Now, some things to really keep in mind, I've done this in earlier videos, is the blue line, the blue dot, I'm sorry, will expand to the current like size or whatever you want to simulate. So that's very useful. And then this little button at the bottom here gets rid of all the hierarchy that's here. Now, I've done something kind of like you're not really supposed to do. I did this -r recursive add in my do file. And what that does is it adds every single variable on all the hierarchy. And so you can see it's quite vast. Some of the actual hierarchy names are repeated. That's because it's recursively going through things. So this is not what you would normally want to do. You just want to show the signals that you would normally have, and that's by the instantiated name in the hierarchy. So you would just do that instantiated name in the hierarchy and add that specifically. I'll try doing a post a little bit later, maybe about that. So let's try to figure out what's going on. So obviously I have an error, let's say in this signal here, that's 0, 0. That's not a really good signal to look at. So we'll start with this signal that's right here, 3524 plus 5E81, and that's in hex. And so what's a really good idea is if you can like get access to a calculator. Most Linux systems do have a calculator that you can use. This one's no different. Make sure you're in hex, so you can put that in 3524 plus 5E81, and that will give you an answer that you can kind of see. Now you can see it says 9x85, which is very, very close to the value that you actually need. So here's how to do this, and this has changed a little bit over the years, mainly because they thought they were adding functionality and they got away from what their simulation engine is in ModelSim. So here's what you do. You put the yellow line where you want to look at, and that will be at a specific time, in this case 74 nanoseconds. You go back to your ModelSim window, that's the main ModelSim window, and you'll have a window, it's called Instance. And it's usually under the Sim main window, and you can usually find that if you go here to the window and hit Sim. Now sometimes that's not enabled, and you have to like sort of add that to the window list, and I forget where that is, but you can easily add another window or look at that. So luckily I have the Sim window up. I think Windows is where it is here, and you can add that value. So you can do Sim window, and then you want to go down the hierarchy into what you want. So here's the top level hierarchy. Here's the test bench, DUT, and I can see that if I go back to the test bench. So you can see my test bench name is Stimulus. That matches Stimulus. Here's my instantiated name, DUT, which is right there. And if I want to look at what's underneath there, I would have to pull up that lower level file. Now, some people like to have their Verilog files in separate files, like me. Some like it in one big file, which is a little easier to debug. However you like to do that, that's your preference. So I keep them in separate files. Here's RCA16. So I'm going to click DUT and the plus line. That's right there. Now what's cool about this is there's a secondary window. It's called Objects. And what you can do is based on this yellow line and the 74 nanoseconds, you can actually see what those values are in that module. Now remember, I'm in DUT, which is not here, but it's in the test bench. So all these signals are in this actual window where it says objects. So you can see I got RCA 16, all this other stuff, and then all that other hierarchy. So if I want to see what's going on, I can look at that signal. I can come over here and see what's happening to that value. Now, I'm having a hard time trying to understand what's going on. I know personally if I go into RCA 16, I know it's a ripple carry adder. So it has a carry every iteration. I can look at the carries. And what I've done, which is I'm not showing here, is I did it on paper, is I did all the carries by hand. So I just wrote down the two signals, 3524 in hex, 5881 in hex, added the two, figured out which of the carries are, and I looked at it and I figured out that maybe I'm have an error that's right here, and you could see C9. Okay, now what is that actually? That's the signal that's there. Now I could look back at the original signal here and try to see what it is, or I could kind of see that C9 is this signal that's right here, which is CPA 10. I could go over to that hierarchy and go down one more and then see if there's something wrong in here. Now, if I go back over to this signal, I can kind of see that I kind of made a mistake and that it should be not C6 here, but C8. Now, sometimes it's harder to see, sometimes it's not, but in conjunction with the sim window and the objects window, you can debug each level of the hierarchy and what it should be. Again, having good files, good golden files, and good kind of debugging techniques are very vital. So I'll exit this out, and this is just showing another emphasis why the do file is so wonderful. I can run the do file again, get this output, hit the blue circle, and you can see I don't have any red signals. And in case of this signal here, I do get 9385, indicating the right result. So I hope that helps a little bit. This just gives you a sort of a start. Really, you have to dive in and sort of get that debugging. But remember, good debugging technique has good vectors, good golden files, and some patience. If you get very upset about what's going on, take a break. I've solved problems that have stumped me for an hour by taking a 5-minute break and coming back. It really pays a huge dividend to actually do that. So I hope you enjoyed that. Have a great day, and we'll hopefully do another one shortly.